Hi, Ben.
Hey,
It's going to be a short meeting.
um, I don't know. There's a bunch of stuff to talk about. I didn't really fill the agenda before. Um, I'm just going to add some notes for now. Um, I don't know if people are going to be able to present today, but um, there's some stuff that Till and Capil are working on for the allocator.
Oh, cool. That looks good. Let me just see if I can find
Um,
that doc.
um, all right, I think Capil or Till might join just to chat about what they're doing. I don't think they're ready yet to um, show a lot of interesting data, but they can talk a little bit about the starvation stuff that they're working on. I think I can probably start with just talking about Flamescope. I actually was playing around with it um, by grabbing some stack traces from the master and agent. I don't know if you guys have seen this tool yet, but Netflix released this as a way to generate kind of a time-based view of CPU consumption. So in this one, it's the master and it's pretty heavily loaded. So it's not as interesting, but if I look at say like a agent, I can see that there's like, oh, interesting. There's like these periodic CPU spikes, and I can drill into one of these and it should generate, yeah, so it's just going to give me a flame graph for that specific time window. And I can see that it's mostly like, okay, real path, like OS real path is 13%. And then the rest is like, so it's like reading, doing lstat for real path, and malloc and free and f open. And I think when I had grabbed some other stacks of this, that was when I had figured out that it was the OS children call. But in this particular one, for some reason, maybe it's because we don't have frame pointers, I'm not sure. It's not showing that here. But that was why I had filed that ticket around OS children being expensive. OS children, I think, it's not here either. OS children is like super expensive because it goes and touches like all the processes in proc. And I guess the only way to improve that was kind of the only major way to improve all the system call overhead is that new system call you were showing, James, which didn't end up landing yet.
Yeah, it seems like there should be a cheaper way to get the children of a process.
Yeah.
Without walking everything. I guess you need to do some kernel code groveling to verify that it's not there.
Yeah, so I can't find a stack right now with it.
This looks super cool. So do you point, so where's the data coming from that
so
Flamescope is looking at?
yeah, so oops. So you run perf record, and then this one makes it kind of, I think it flattens all the stacks. Like it kind of just makes the file include like a massive collection of stacks. Usually this file is a lot bigger, so you run this like file that massages it into like a format that I guess scripts can understand more easily. I'm not quite sure why it's a separate command, but maybe it's just a lot bigger of a file. And all you have to do is take this file and drop it in Flamescope's examples folder, and it'll show up, and you can start using it.
Cool, that seems pretty straightforward.
I ran it through CPP Filt like they suggested. I guess that helps a little bit, but just with like the weird template stack names. But I'm not, at this point, I'm not sure if we turning off frame pointer omission will help. I didn't quite understand why. Let me find the link. So in here, there was a comment about perf event supporting a workaround for missing frame pointers. libunwind, which uses dwarf. This can be enabled with callgraph dwarf. So in the master stacks, I actually used that. I passed that in. And I think they were better, but I haven't had time to more rigorously compare. Okay, yeah, there's this bug in Flamescope where sometimes this happens. It throws an exception, and I filed an issue with them, but I'm not sure what triggers it exactly. Okay, here it's all right. Here it looks like, maybe we're getting a little bit more, like process manager resume is showing up. This looks like metrics, but I don't know why it's showing up in the await process. I would expect that it is spending its time in like the master and allocator and so on, computing gauges. But instead of this shows up. So I'm wondering if that's because we don't have frame pointers, or if it's just been optimized and inlined or something. I'm not sure. But we get a lot more, like it looks like we might get, I don't know, we might be getting more when we pass this workaround, but I'm just not sure if this workaround is actually I'm not sure if it's comparable to having frame pointer omission turned off.
Yeah, I haven't looked at this for a long time.
Okay.
I remember at least, so our internal builds are not very complete, I guess. So trying to get dwarf support in the right places with tool chains and symbols and the right kernel package, and there was a bunch of packaging and distribution issues which made the dwarf sort of unreliable or hard to get. So frame pointers are easy to enable and seems to work in the cases that I could see. I don't know how mature the dwarf stuff is, especially in Mesos, because there's a ton of dwarf. Like the dwarf is huge, and I think you might need. I don't know if you want to do the extended dwarf that. So there's like, I think there's minus G GDB3. So there's a lot of different knobs to twiddle around this area that is pretty time consuming to explore all the possibilities.
Okay. Yeah. I also just don't understand what's happening under the covers to make this. I think Chun was telling me that it looks like it might be that the dwarf information includes the stack frame size or something, and that lets perf know where the how to jump to like the previous frames and so on.
Yeah, the dwarf should have enough information to let like a stack walker do things like figure out that a function got inlined and that you're really in an inline function and present that as a stack frame, and it should be able to
to a similar degree that the frame pointers can provide that, or even more in that case.
I'm not sure if you get a frame pointer if the function's inlined. Like there might not even be I'm not sure if there'll even be a frame there.
Yeah, probably not. So in that situation, this might be like better.
Yeah, I think theoretically the dwarf is better, but I mean Mesos generates like gigabytes of dwarf, so
Yeah, so and the other thing is that this flag is like one or the other. It either uses FP or dwarf or LBR, but it doesn't seem like it can use both for some reason. Which seems a little bit surprising to me. I would imagine that you could use both together to get better information, but I guess not.
Hi, James. In your experience, have you ever like just compile Mesos and use Mesos with frame pointer on?
Are you asking me?
James.
Oh, James.
Yeah, we do that all the time. Our build has done no omit frame pointer for like years now.
And there is no significant performance problem, right?
Well, I don't know. I don't have a benchmark to really show the difference.
I see. Maybe we can consider also turning on.
Yeah, Benjamin has some patches.
Oh, okay.
Where he's turning it on for if you pass enabled debug, but I was kind of asking him whether it should be on always.
I think for quick and dirty, you could just enable and disable the flag and run the benchmarks that are in Mesos. That's much more reproducible than anything you get in prod, and I expect that'll probably give you at least a sense of whether it matters.
Yeah, I'm guessing also that enable debug might actually help the dwarf stack tracing, just because we only do G1 by default, which is, I assume, what I was using on that box that I was testing on.
Yeah, less aggressive optimizations will give you better stack traces too.
Well, is that what -G without a number? Is that what that's going to do?
No, -G just generates debug info.
Okay. Yeah.
And it's like orthogonal to the optimization level. You can do -O. You can do -OG, which is supposed to optimize but still make your code debuggable. But at least my experience of trying to get debug stuff in Mesos is that it's not debuggable enough. So if I needed to debug it, I've usually had to go to -O0.
Okay.
I think anyway for Mesos, the performance bottlenecks in Mesos are not really around compiler options in general. It's more about, I think still the high order bits are moving how things get allocated to processors and memory, and that kind of thing. I think tuning the frame pointer is probably pretty marginal at this point.
Okay. Yeah.
This flame scope is super cool though.
Yeah, this is a master example where it's like this master is using almost 300% CPU, and you can see it's spending time like allocating. And I noticed that it was actually like there's a big chunk of that which is just computing the available resource on the agent. The subtraction operator is actually very expensive. So yeah, we've already seen a lot of interesting stuff come out of this. I actually wanted to.
Yeah, it's kind of consistent with historical performance issues we've had, where where we've hit expensive operations around resource arithmetic. So that kind of that consistency
it looks like
encourages me to believe its results.
Yeah, it looks like that we've managed to make the addition. Here's that bug again. It looks like we've managed to make the addition very efficient because I don't see it showing up. But this looks like JSON responses, because in this particular cluster, I mean, the JSON endpoints were getting hammered. And then the allocator, and this looks like metrics to me. It's showing up a little bit weird, and then it's coming in and weighted. But I suspect that this is waiting for all the doubles of metrics. It's just this code in itself is very minimal. I'm not sure why it shows up as this instead of, like, let's say, the gauge functions. But that's what I'm guessing this is.
It might be the sample rate. What was your sample rate for perf?
It was the default, and I picked, and this is 20 milliseconds here, so it's pretty small window. I can't grab a big window in this graph for some reason because it's going to hit that bug. Yeah. So this is a broken flame graph. I filed a ticket with them. They haven't responded yet, but yeah, I seem to hit this whenever there's, I don't know, a lot of data. I'm not quite sure exactly what's triggering it. So in this graph, I can only really look at like small little windows of like maybe 30, 40 milliseconds. And then, yeah, and this is always what seems to show up here, weighted. Anyway, it's pretty easy to use. I'm hoping other folks can make use of it and share interesting flame graphs. I'm also hoping we can update the profiler endpoint to maybe make it very easy to just get one of these files back without having to get onto the box and run these commands and SCP this stuff back. Hopefully you can just hit an endpoint and get the file, and then we could take the file and put it in Flamescope.
Would that, though, end up sampling itself? Because if you have an endpoint on the agent or master, which is then doing the exec of perf, I guess there's not that much code waiting for perf to finish. Right?
Yeah, it's just going to be the subprocess waiting, which should be pretty minimal, right? But yeah, I know one thing I ran into when I was trying to do this, I think with Chun was helping me, was there's this flag, like by default, it will actually grab all the sub processes stacks. So I was running it on an agent and I was getting all this JVM stuff. And I was really confused. And then I realized you had to pass -I or something, -- no inherit, to get just the process that you're passing with the PID parameter. That's just a little gotcha if you ever try to do it on the agent. Anyway, that's Flamescope. I think it's really interesting, pretty useful tool. Hopefully we can start using it more. Yeah. Does anyone have any questions about it, or?
No, I think that looks really cool. Thanks for digging into that, Ben. It's really, really promising.
Yeah. Okay, let me just take some notes here. So Kapil, well, let me talk about one more thing before we talk about the allocated starvation stuff. So the other thing I was going to talk about was, I don't know if you guys experienced this, but because of the fact that we're using pull gauges for a lot of the master and allocator metrics today, the metrics response can be significantly delayed, as well as it can induce a lot of CPU consumption on the master and allocator actors. I assume that you guys are maybe just pulling it from one thing, like a metrics monitoring system or something. But I think in some other cases, people are pulling it from different sources, and it might be getting pulled pretty frequently. So what I'm hoping to do is migrate all of the existing pull gauges, or graph, to push gauges, so that when you hit a metrics snapshot endpoint, it's returned pretty immediately. It doesn't have to trip through any actor queues. So I think Zitao from Uber mentioned he was going to help with that. So hopefully they have someone who can contribute that, and we can help review it, and we actually follow through. Otherwise, we can just do it piecemeal over time, and hopefully we're all aware to not add more pull gauges, but if any more slip in, we can migrate those as well. I just wanted to mention that so that everyone here was aware of it. Okay, if there's no questions about that, we could talk about, Capo could talk about a little bit of the allocator starvation benchmark work that him and Till have been working on.
Can you guys hear me?
Yeah.
Okay, so I don't really have much to show as such, but I will just actually talk a bit about what we have been doing in terms of the benchmark and what do we expect. So hopefully by the next meeting that we have here, we'll be able to present some numbers to actually get more feedback. So anyway, just to actually give an overview of what is the problem that we are dealing with, I'll just start with the scenario where we have a bunch of frameworks that are registered with the master, and of those frameworks there might be a class of frameworks which are actually resource hungry, as in whatever resource is thrown at them they'll actually accept it, and will have always some jobs to launch and so on. And then there is a different class of frameworks which actually doesn't care about many resources. So if you are sent an offer, if you send an offer, they'll actually accept maybe like half of them, or maybe like only a fixed number of offers, and they keep declining everything else. The way DRF works is when it is time for the next allocation round, it puts the frameworks in a priority queue, where the highest priority is given to those frameworks which have not used their fair share yet. And so what DRF will try to do is will say, okay, these are the 5 agents that I have, for example, and out of these 20 frameworks, I have 5 frameworks which have used less than their fair share. So let me send the offers to these guys. Now, when you do that, these 5 guys will not accept this offer. If they don't accept this offer, then they'll decline the offer, and implicitly, if they don't do anything else, they are actually setting a decline timeout, or the refuse timeout, to 5 seconds, which means they won't be receiving any offers for the next 5 seconds. And that works well. The allocator then goes on to the next set of frameworks to offer these resources, and the next set, and so on. If we are in a cluster where we have a lot of these frameworks which will just refuse the offers that are sent to them, eventually you'll see that after some time there will be their timeouts which have expired in the allocator. The refusal timeout has expired, and so they are added back to the queue, the original 5 frameworks that refused offer. And so at that point it becomes sort of a situation where the initial, say 20 or 30, or like a small set of frameworks, is the one that is getting offers repeatedly, whereas the guys who are actually using resources at the time, they are actually at the back of the queue due to the priority queue, the priority. They will never get any resources back. They will never get any resource offers, and that is what we call the starvation. Just to actually show you some numbers, actually I'll just actually talk about some numbers. So I ran this experiment with 25
so just let's pause for a second. So does everyone understand that scenario that Capo was describing?
Yep.
Okay, great.
Okay, so I ran this experiment. Actually, maybe I can just paste these numbers in the document in a second.
Yeah, feel free to share your screen too if you want.
Okay, let me do that. Ben, you have to actually stop sharing, I think.
Oh, okay. Let me do that.
Okay. Just one more second.
Yep.
Trying to select the app. Can you see the screen?
Yeah, I can.
Yep, you can see it.
Okay, so on the left, what you are seeing is this matrix. So let me explain what's going on in here. So the first column is the framework ID. In this particular test, we launched 25 frameworks, and there were, I think, 5 agents. Yeah, so 25 frameworks, 5 agents, and we actually did this decline timeout. We actually, to make it synthetic, we set the decline timeout to 1 second. So every time you decline an offer, you will be actually also telling the master that you don't want to receive any offers for the next second. The default value is 5 seconds, but this makes the test run quicker. And then what we have is we have the some frameworks which are actually accepting a fraction of the offers that is sent to them, and others are not accepting any offers. So in this table that we are seeing, the first column is the framework ID 0 through 24. The second column is the total number of offers that this framework received. The third column is the total number of offers that it accepted. And the fourth is the total declined. So interestingly, what you see is the first framework, because it accepted an offer, like it declined the first offer, but as soon as it accepted the like one of these offers and started using those resources, it never received any more offers back. The same thing happened with framework number 1 and 2. The reason why framework 1 and 2 see more offers is because they accepted the initial offer after quite a while. So they kept rejecting several offers, and then at some point they accepted an offer. As soon as they accepted the offer, they never got any new offer back. And the frameworks from number 3 all the way down to number 24, they were the ones which were repeatedly offered the resources, and they kept repeatedly declining the resources. So that's pretty much the offer starvation bug that we are looking at. And Mang actually is working at the patches for addressing them using the exhaustiveness thing. So for the benchmarking, what we are planning to do here is we'll actually define some sort of goal state, and the idea will be, let's run this benchmark and see, let's say if in this case framework 0 actually gets an amount of offers or not with the new fix. So, or actually how long it takes to get it the n amount of offers, and so on and so forth. So that's pretty much all I have in terms of the topic at hand. Any questions?
Yeah, I just wanted to mention that I'm planning to send an email today just to kind of describe this issue that people run into, and how we're looking to, what our options are to try to address it. After having looked into the exhaustiveness approach more over the past few days, it's actually a little bit more complicated than we thought, and it's a little bit not clear how it's going to fit in if we make roles hierarchical. So it's a little concerning for that reason, but I'll kind of talk about the different options we have, and folks can give some feedback there on the email thread.
Okay.
The other part that I guess was interesting for this group was that Till grabbed some profiles. Let me try to grab those from him. So yeah, he found that there is some low-hanging fruit in the allocator. There's like a lot of slave ID copying being done, and it actually shows up quite heavily in the in the profiles that he got. So as part of just running this benchmark, we've also just found some room for improvement. It probably shows up in some of the other benchmarks too, but I think now we'll probably take a look at those and see if we can fix some of the performance problems in there. But the performance is kind of orthogonal to this problem. This is going to happen even if the allocator is really fast. Yeah, we can discuss this more if people are interested, like what this problem and the options that we're kind of looking into, but I don't know if it's, I think we probably need a resource allocation working group soon.
So given the parallel work on the framework metrics around allocation and DRF, do you think we could use those to build some kind of tool which creates a profile of how allocation is happening in your cluster that we can then, you know, build benchmark models of?
Yeah, it's a good question. We're actually adding those metrics because of this issue. So,
because I think it'd be pretty cool for me to, like, I haven't looked, I looked briefly at the doc. I haven't like studied it significantly, but maybe I could write something which will sample those metrics over a few hours, anonymize it to produce some kind of table or some kind of parameters that we could then feed into this benchmark. Then we could kind of have a way to share our production experience with
yeah,
the rest of the wider community.
Yeah, so that's kind of what we ended up doing, but without using the benchmarks or the metrics. We just kind of, we've been running a particular set of scale tests where frameworks behave particular ways. And so we've kind of encoded one of the worst cases here in this benchmark, where everything is just declining without any large timeout, and they don't suppress. There's still issues even if they're trying to be good citizens, but this particular benchmark, we just took the worst case, which a customer actually ran into because they deployed a framework that was written by, wasn't supported by us, but it was, it just had like a default 5-second filter, and that company was running hundreds of frameworks, I believe. So those started starving all the other frameworks because they had a low share of the cluster. So yeah, we're kind of looking at the worst case here. Hopefully that's sufficient. And in the future, we could start modeling other setups. And metrics would probably help us figure out what those setups look like based on how they decline, how they suppress, and so on. But I kind of hope that we don't have to, I don't want this to be like a rabbit hole that we go down where we kind of keep trying to optimize various setups. I hope we can come up with something that kind of addresses the problems more broadly. And I think in the longer term, like, I don't know if these will be problems. I kind of think these problems are a little bit symptomatic of our model being not a good fit for the use cases. Like, we still have DRF from the fact that the paper was written based on DRF a long time ago. And I think for a lot of our users, at least, they don't really need DRF. They often don't overcommit their clusters. So there's often not contention. And instead, they just have resources that are free, and they want anyone who wants them to be able to get them And then they care about certain things like guarantees and so on. So I think DRF probably is going to come into play more where we're running in a revocable world, and things could be contended there. But from what I've seen from most of our customers, at least, in the non-revocable world, there isn't this issue of overcommitting and there being contention and us needing to figure out who should get how much. They mostly care about their guarantees from quota and getting that satisfied if they're under contention. So yeah, I think us making allocation decisions is, I don't know how sustainable it is. We might have to move to optimism at some point before this gets too out of hand. But for now, we're just trying to address the current behavior and try to make sure that it's a little bit better for these cases where things are starving. I don't know if you guys care about DRF or if like a round robin thing would be perfectly acceptable. But that was another option we were looking at, was changing the sorting to be just round robin between roles and frameworks.
Dario, do you want to comment on that?
Sorry, I was a bit distracted.
It's okay. I'm just kind of rambling on about how it turns out that, I mean, DRF was added a long time ago and the assumption that DRF had was that there's congestion. There's far more demand than the cluster has capacity for. And it kind of addresses the problem of, well, what to do in those cases, like how to kind of maximally utilize things when there's a lot of congestion. But most of our customers' use cases have been, there isn't this issue of contention, and rather they have free resources and they want anything that needs resources to get them. In those cases, like DRF doesn't really add a lot of value for them. So I was kind of just explaining that one of the other options we were looking at to address starvation was to provide another sorter, which isn't DRF, but instead is just round robin. And that way we hopefully cycle through roles and frameworks more evenly than where we cycle through just the low share stuff and don't reach the high share stuff.
Yeah. So I think DRF, yeah, for us it's basically the same. It does not add a lot of value in most cases, and it actively prevents frameworks from getting offers in other cases. So I think round robin would definitely be an improvement in, I hope, most cases for us. But I also think that a request-based model would probably be helpful, because in most cases we know exactly how many resources we need.
Yeah.
So that would definitely help us. For other cases, a round robin thing would definitely also be good. And then, I mean, quota-based things and so on are anyway separate from that issue, so, or somewhat separate.
Yeah, I agree that request directly tells us what the demand is, and then we can satisfy that more directly. Quota is like we can infer a demand from that. It might be a little bit too high, higher than it should be, but it's like we can get kind of close to what their demand should be, hopefully. But I'm hoping that I'm hoping that before we build too much complexity into the current model, we can consider migrating towards a more optimistic model where in a non-revocable world, at least, we just let it be a free for all where we impose constraints like you have a limit, or there's like a opt-in attribute here that you can't get unless you're opted in, and things like that. But within that, people can just consume things that they want, which I think is kind of more of a sustainable approach. But that's a little bit far away at this point. So right now we're just trying to add more mechanisms to make the current approach last for a little bit longer. Request could be yet another tool to help us with that.
Yeah, totally. I mean, I feel like a round robin should also not be hard to implement. Should be pretty straightforward. So once that's in place, we could definitely give it a try and see if and how that improves our situation.
Okay. Yeah. So that was one of the approaches. The other approach was something we called exhaustiveness, where we could either do round robin or DRF, but what we would be doing is ensuring that if a framework declines an offer, everyone else gets a chance at it before it would go back to the same framework. That's the kind of exhaustiveness property that we've been describing. That is a little more complex to implement because we have to do quite a bit of tracking. But it provides a guarantee that, a stronger guarantee that everyone's going to see it. After having looked into that approach for the past few days, it's a little bit more concerning now than the round robin one, but
so the exhaustiveness sounds a bit like, I mean, it is somewhat similar to setting filters, right?
Yeah.
So we have had issues in the past with setting too many filters, where the allocation times just skyrocketed, and that is definitely something that we have to be aware of. Like we unless you find a magic solution for that, then I would be perfectly fine with it. But we've definitely seen problems with filters in the past, and so we can't use anything like that if it's not like super performant.
Okay, yeah. It definitely has the exhaustiveness one definitely has a performance overhead because we have to track. We have to have a per agent set of the roles and frameworks that have been allocated to for that agent. And that has to fill up essentially and then get cleared. I have seen some performance problems as well with filters where because they're resource subset based, you can actually build up a lot of different filters on a single agent. And that starts to get really expensive because we have to check all those filters. And they're all like slightly different subsets. So I hope that that's what you guys have been hitting.
No, we've just set complete filters, like do not accept any offers from this node unless it changed, right?
Right, but do you know how many there were per agent for a particular framework?
I would assume only one.
Okay. I think what can happen.
We did not filter based on any resource type or anything else. We just checked, does this match offer match? If it doesn't, then we're just gonna filter it for the next round, or for
okay.
how long ever.
And is there things like reservations involved, or?
No, that was way back. That was
okay.
I don't know, maybe 2.5 years back.
Okay. Okay, so it shouldn't be a lot, but it could still be several, given that we could start sending you some amount, and then that amount could grow a little bit, but it's still not enough, and so on. And each time would be a different Like some of them are subsets of each other, but we don't actually check for that. We actually store all, like if you filter for a superset of what we previously have to filter for, we won't get rid of that earlier subset filter. We would leave it. So we would have 2 at that point. So that could be happening, but yeah, maybe for you guys, it's a smallish number. I think hopefully now that we have, things like flame scope, it would be great if you guys ever run into any high utilization or performance problems, just grabbing a flame scope and then sharing it with folks, and we can all drop it into the tool and take a look at what's happening.
Yeah, sounds good.
All right. I think that's it. I'll just take a note for myself. We can break early, or if anyone else has something they want to discuss in the last 8 minutes, can bring it up now. No? Okay. Thanks for joining. I think hopefully we can have some more interesting stuff to show around the benchmarks in the next meeting. Yeah, I'll try next time to send out an email and remind folks what the agenda is going to be and stuff like that. All right.
Cool. Thanks a lot.
Thank you.
Thanks, guys.
Bye.
Thanks.